good morning or afternoon, depends on what time you are watching this. I obviously am not here today. I'll probably be driving down to Georgia during your class, so I might not be able to answer your emails, but when I get to my hotel room, I can totally check my email and answer any questions that you may have. So, for today's lesson, I wanted to tell you about the giant impact theory. If you click this title in the slideshow, it will produce a video that you can watch that might explain the giant impact theory in more depth. But essentially, this is the idea or the theory of how the moon formed. Now, we're not quite sure. There are a few theories out there, but with the evidence that we have, this is our best guess. Again, it's called the giant impact theory. So, what happened, or what we're theorizing, is that long ago, about 4.5 billion years ago, there was another planet called Theia, after the Greek Titan. And Theia was orbiting the sun, but something hit Theia and caused it to be off course. They're thinking a comet or an asteroid or something like that. Regardless, it started hurling itself towards the Earth. Now, Earth was still in its new form. It formed 4.6 billion years old, so it's only 0.1 billion years old at this point, still forming, still molten, still hot. Theia hits into the Earth, and when it does, it causes a gigantic explosion that's said to be about 100 million times the size or impact of the meteorite that killed off the dinosaurs. So, a really big explosion, a really hot explosion, and it caused the Earth, if it wasn't already molten, to become molten at that point. Now, that allowed all of the liquid layers and all of the core of both the Earth and waiting for the bell. There we go. To kind of mix together. Some parts of Theia and the Earth did kind of get sprinkled out into space, and they will later congregate together. So Theia hits into the Earth. Not only did it hit into Earth, but it also caused Earth to tilt. And this is why we have a 23.5-degree tilt, which is what causes the seasons. So all because of this theory that Theia hit into the Earth. So it hits into the Earth. We have a whole bunch of new material on Earth, but we also have a lot of material that was sprayed out past Earth. And it starts to congregate around Earth because remember, Earth has a gravitational force just like the sun. And so any material that's near Earth is going to start to orbit around it. Now, as it orbits around Earth, it's going to start to collide into each other, becoming a little bit more massive and a little bit more massive, and basically creating its own gravitational force by congregating all these masses together. Eventually, they all come together and form the moon. Now, the reason why we think that this is the true thing that happened is because of seismic, not activity, but seismic tests that the Apollo 11 crew, I think Neil Armstrong, Buzz Aldrin, those folks. There was one more, I just forget his name. They did some tests, and when they looked at the seismographs of the moon, they noticed, because waves move differently through different types of liquids and different solids, they noticed that it was very similar to the Earth. So they're thinking that material from the Earth and material from the moon are the same. Well, how could they have been the same? A piece of Earth must have broken off and formed this moon, or therefore, again, Theia added some material to the Earth, and some of the Earth material went out as well into space, forming this moon. So I know it's a little weird, but the premise is an object collided with Earth. It caused some material to be sprayed out into Earth. That material eventually congregated together to create the moon. So that's this theory of giant impact. I do suggest you go back and click on this title because, again, there is a video to show it all, and there's some really good visuals in there as well. All right, feel free to pause me, obviously, at any moment for your note taking. So next, how big is the moon? We have measurements of the moon, and it basically roughly comes out to being about a fourth of the size of Earth. If you want to put it into perspective, which is what this photo shows, it's basically the size of the United States of America, which is kind of crazy to think about. So it's 1/4 the size of the Earth in its width. And then if you wanted another point of comparison, our dwarf planet Pluto, the 9th planet from the sun, it is 2/3 the size of the moon. So Pluto is actually smaller than our moon, which is kind of crazy to think about. So again, 1/4 the size of Earth, and then Pluto is 2/3 the size of the moon, to give you some perspective. All right, so there are 3 features that we're going to talk about, 3 moon features. There are more that are out there, but these are the ones that we'll focus on for Earth science. The first one are lunar craters. So just like a crater that might appear on Earth, it's when an object, a space object, hits the surface of that planet, or in this case, the moon, and creates a dent. Just like if it were hailing out and that hail were to fall on your car, it would leave a dent. Or if you were to walk in the mud, your footprint would leave a print, or a footprint in the mud. So it's basically very similar. An object hits into the surface of the moon and leaves a hole. It leaves like a crater-like shape, a little dome in the surface. So that's the first one, lunar craters. And the moon, whenever you look at photos, is filled with these craters. They almost look like dimples, just completely filled with them, which if you compare the moon and Earth, Earth has an atmosphere, has very little meteorite impacts. The moon does not, and has a lot. So think about the fact that, our atmosphere really protects us from all these different debris. It burns it up in the atmosphere and protects us from a whole bunch of explosions and impacts, which is of course good. All right, next up we have Marias. Now Marias are pretty cool. I really like them. And what they are is they're essentially giant craters. So think like a giant space object hit into the side of the moon, so big that you can see all these different Marias. These are the dark spots, like birthmarks, if you will, kind of giant darkish features on the moon. These are these Marias. They're giant craters that they go so deep that eventually it actually hit the mantle of the moon, and it caused the lava to fill up to the surface. So they are flat features, but they're craters that filled in with lava because they went so deep, it exposed the mantle basically, allowing the magma to rise up. So those are Marias. The reason why it's called Maria, though, is because Mar in Latin means sea, and ancient astronomers, when they looked up at the moon, they thought that these dark features were oceans. I guess they're not quite off because it was, a depression in the ground filled up with something, but it wasn't filled up with water. It was filled up with lava. So they're not seas like Maria suggests. Mar, think like Spanish. Mar means sea in Spanish. It's not that. It's instead lava-filled craters. So one famous one is the Sea of Tranquility, which is right here. And this is where Apollo 11 landed in 1969. You don't have to memorize that, but it is a really cool piece of knowledge. And then the last thing are lunar highlands. And basically a lunar highland is any of the more whitish features. It's going to be the areas that were not impacted by craters. There's no depression there. It's kind of like the original surface, if you will. So that is what a highland is. It's the area that's not depressed. There's no crater, no giant craters. There can be little craters, but its surface has pretty much remained intact and has not been depressed at all. That is a highland, which, like its name suggests, is higher up than the other areas. All right, so feel free to rewind that if you need to. Pause at any time. When you're done with these notes, what I want you to do is some JLabs. I'm not sure if you're familiar with JLabs, but I'm going to make it into a competition. So the next slide, there's a JLab competition, which actually, is it going to let me, hang on, I have this as a view tab. I don't know if it will let me show this tab. Okay, I figured it out, so sorry if there's a cut in the video. Anyways, you're going to go either into the slideshow, right here, it's listed on slide 24, or you can go into Schoology. I made a separate folder, if it loads. I made a separate folder called JLab links, and that's where you can click on the link for the website or the link for the Google form. So JLab is a website where you can practice questions that have been asked on actual SOLs before. You can do this for your math SOL or, of course, your earth science one. So you'll click on earth science. You can choose the number of questions. For today, I want you to do 20. You can do more, though, if you want to. And if you want to, you can either just, I'm ready, let's start, or if you want to focus on a specific part of earth science, you would click select additional options. And what that's going to allow you to do, if you click next and then next again, you can pick the specific types of standards you want to focus on, or groups of science subjects. So for example, Earth and space systems, that's a really good one because that's what we're talking about right now. You might want to hold off on cosmology since that's going to be part 2 of astronomy. So this allows you to really focus what the questions will be on. Either way, this is what it'll kind of look like, and I'll just do a 5-question one real quick just for ease, but know that you are doing a 21 today, right? Oh, earth science. Okay, ready? So it'll give you a picture, or it might, you are going to choose a choice. I'm just randomly clicking through. So no, this is not my ability to do earth science. I'm just trying to get to the end real quick because at the end there is a number that they will give you, and I want that number, and I'll tell you why after this last question. Okay, all done. So it'll give you this number. You can definitely record it because you can use this number to go back into JLab and look at your previous questions. So for example, I can copy this. I can click start over. I can click this blue button, view one of my old tests. You do have to do a like I am not a robot security check. And then you post your code, and now you can view. So this is why it's important to collect that number, because we're having a competition, and whichever class after the SOL, it'll end the day of the SOL, whichever class has the most points per person, because obviously I have different numbers of students in each class, they are going to get a movie and a snack, basically a movie party. So I'll get some snacks for you guys and some drinks, and we'll put on a movie if you are able to get the most points per person. So how do you get points? You're going to go again into that JLab folder, click on the JLab Google form, and it's going to ask you to fill in your first name, last name, and then the block you have Earth Science. That's really important because you want your points to go towards your team. If you accidentally select the wrong one, just let me know and I can edit it in the Google form or in the Google Sheet. But if you don't tell me, I might not check your block. So make sure that you put your correct block. And then this is where you would paste that code that we talked about before. So what it'll look like on my end, let me make this bigger. What it will look like on my end is this. A person will do a JLab. They've given me the code. I can then copy that code, put it into JLab, like so, and I can see however many they get correct. Now, because I was randomly clicking through, I only got a 40%. And I know some of you might want to do that. Don't, because you will only receive points if you get over 60%. All right, so only over 60% gets you a point, and the points will be awarded based on the number of JLabs that you did, or the quantity of JLab that you did. So for example, if you chose to do, and I'll show you on the website, if you chose to do a 5-question JLab, that will be worth 1 point. If you do a 10-question JLab, that will be worth 2 points. To incentivize you to do a little bit more, instead of 20 being worth 4, because if you get it, it's about like 5 questions is 1 point. But to make it a little bit more enticing, 20 is going to be worth 5 points instead. And then 40, instead of it being worth 10 points, if each 5 questions were worth 1 point, it'll be worth 12 points. So you'll get the most value here by doing the 40, and that will help you practice for your endurance for the test, since your SOL is like a 50, or I think it's around 50, maybe 60 questions. So anyways, if I go back to my form, you can see that because I have the code, I'm able to copy this into the area where I can test or view my old test scores. I can see the score that they received. Hang on, where did I go? I can see the score that they received, and once I've approved it, I'll write down, okay, they did a 20 question JLab, and then they received 5 points. So you can see my first block already has a decent number done, my second block also. And so when you do your JLabs, it will populate into this Google form, and then I can edit the number of points. So I'll add up these points, and I will divide it by however many students are in that class, not however many people submitted, but for example, my first block has 15 students, so I would divide this number by 15. My second block has 20, so I would divide whatever their points are by 20, because it's a per person score. That'll allow the classes that have less students to be able to match the classes that have more students. So again, what you're going to do today is a 20 question JLab, and you can do the JLab through Google or through Schoology in the JLab links folder. You click the website to get there. At the very end, you'll get your number. You'll post it into the Google form. If you have any questions, let me know. Feel free to email me. I'll probably be able to respond in the afternoon. It's going to be a busy weekend. All right. See y'all later.